Hello everyone. So having a question from Sensei, and I would like you guys to discuss this with me together. So next time when Sensei asks me again about this question, I can be remembered because I have discussed it with you guys here in TikTok. So this is the question. Here we have the molecules which have phenyl group here, and this one here, and also another group which is bromine group and methyl group, and they are drawn in this kind of structure, wherein the bromine group here is with this bold bond, means that this bromine position is directing towards the reader, right? Meanwhile, the methyl group is drawn here, which is drawn away from the reader. And here is the question. The question is this one. Draw the structure of the main product of E2 reaction of the compound above. E2 reaction, okay, please focus on that. And then in case the main product shows J-strand isomerism, clearly draw which is obtained. Here, the focus is about E2 reaction. You may already know that the reaction for elimination reaction, there are two types, which is E1 and E2 elimination reaction, right? Here are clearly obvious that E2 reaction means there are two substrates, two molecules that involved in the elimination reaction, which is the substrate itself, and then the base, right? The substrate and the base. Meanwhile, for E1 reaction, it is obvious that only one molecule involved in that reaction, or important in that reaction, which is only the substrate, right? That's why this is called here is the molecule bimolecular. Meanwhile, this one is unimolecular. Another difference is E2 reaction. Since there are two molecules involved, the reaction becomes fast, so it's only a one-step reaction. Meanwhile, E1 is a two-step reaction because it goes slowly, because only depend on one molecule, which is only the substrate. That's why the reaction reacts slowly. Okay, let's focus back to the question. The question is about reaction of E2 reaction. So the previous explanation is just a reminder for it. So let's be back again to this question. And this question is asking about the main product of the molecule if it goes through E2 reaction. Let's rewrite again the molecule. Here is phenyl. It might be already clear. This is a phenyl group, right? And then we have bromine group as the living group, and we have methyl group here. For the elimination reaction to proceed, it requires the living group, which is the bromine group, to leave, right? This one, it should leave. Another else is to have the proton to be withdrawn by the base. So we need to know where is the proton. The proton is here in this, and then another molecule is here. But for elimination, of course, this proton matters, not this one, because you are going to have a double bond means like the proton must be from the neighboring carbon, which is here. So the double bond will be here, right? So bromine will leave, and then the proton will be attacked from this neighboring side. Okay, so the hydrogen that is matter is clearly this one. However, for elimination process, the position of both atoms is preferably in anti-configuration. What is anti-configuration? How about this configuration? What does it called? What is it called? This is called as syn configuration because both atoms are in the same side. Configuration. So what is anti-configuration? Anti-configuration is when bromine is here and the hydrogen is in the other side. So this is called as anti-configuration. It's obvious why anti-configuration it is more preferred for elimination reaction because this is less crowded. The base can attack from this side and the bromine group can leave from this side. So this is a clearly different side. This side and this side. If those things happens in the same side here, like here and here, it would be so crowded, right? It's crowded, so that's why it's avoided, and that's why anti-configuration is more preferred. And somehow it never happened elimination via syn configuration, we can say that. So in this question, is it possible to proceed elimination reaction even though the hydrogen is in syn configuration with bromine? Still it can process. How come? Maybe you may ask, like, how come? This is because this is a single bond. Single bond means every atom bonded to each carbon can rotate, and then there is situation when the hydrogen can be in syn configuration. Okay, so if you zoom this in, this hydrogen can be rotate, right? Can be rotate, and then it can be here, so then this can be here, so it can rotate easily. So there is still a possibility for this molecule to proceed to the elimination because this is a single bond and single bond can rotate, so that's why the elimination reaction can occur. It will be clearer if we draw this in Fisher projection. So imagine here we have this Fisher projection, and then I'm gonna draw this side, okay, this side in the front, and then I'm gonna draw this side in the back side. So the front side is here, and then the back side is here. Okay, so imagine this blue color is in the front side, so we can put bromine here in the left. Let me use blue color to emphasize it. Anyway, it's going 10 minutes, so I'm gonna continue this in the next video. Please move to the next video to have more detail and to get the answer about this question.